So the next session, in this session we are discussing on problems on wave equation. It comes under partial differential equations application. Solve the wave equation dou square u by dou t square equal to c square dou square u by dou x square, given that u of 0 comma t equal to 0, u of l comma t is 0, u of dou u by dou t is 0 when t is 0, and u of x comma 0 equal to u naught sin pi x by l. So in any problem on application, the first three conditions will be same, the third condition will be different. So any problem asked in wave equation, in the first three conditions, till first three conditions we have to derive the solution, and then we have to use the last condition. For that we have to take the solution u of x comma t equal to a cos px plus b sin px into c cos cpt plus d sin cpt. This is the general befitting solution of wave equation. In that I will start from first initial condition, u of 0 comma t is 0. That means when x is 0, u is 0. If I substitute x 0, cos 0 will become 1, sin 0 will be 0, this term will remain as it is. When two products are 0, each term is 0. So a is 0 and this term 0. But if this term becomes 0, if you see the solution, if this term becomes 0, 0 into anything 0, so the solution only will not exist. So we must have a 0. So by putting a 0 and the second condition, u of l comma t is 0, that is when x is l, u is 0, we end up with 0 is equal to b sin pl into c1 c cos cpt plus d sin cpt, because x you are substituting here and you are putting a 0, so you end up with this. Again, when two products are 0, each product is 0. Again, if this cannot be 0, since a is already 0, b cannot be 0, because if both a and b become 0, again solution is 0. So this first procedures will be same for any problem, first three conditions, so you can memorize. Then so if b is 0, so only this term can be 0, that is sin pl is 0. So sin pl is sin n pi, so pl is n pi, so p is n pi by l. So using this p in the main solution, we end up in this one, we end up with the equation u of x comma t as b sin n pi x by l into c cos n pi ct by l plus d sin n pi ct by l. And I am using the third condition, that is dou u by dou t is 0 when t is 0. I am differentiating this u to get dou u by dou t. So b sin n pi x by l will be constant, differentiation of cos is minus sin, and differentiation of sin is cos, and the constant I am writing for both same, so outside. And I am using the condition dou u by dou t is 0 when t is 0. So you end up with 0 is equal to b sin n pi x by l into d into n pi c by l. Again, since b cannot be 0, we should have d should be 0. So using d equal to 0 in equation 3, you end up with u of x comma t as bc sin n pi x by l into cos n pi ct by l. So this is given in the notes also, you can follow this. So at last you end up with the equation u of x comma t equal to summation n, because we have to do it for different values. bc is converted to n, so it is bn sin n pi x by l and cos n pi ct by l. So till here, whatever the problem is asked in application related to wave equation, you have to do till here. Then the last condition, u of x comma 0 equal to u naught sin pi x by l. So I am using the condition, put t equal to 0 here, cos 0 will become 1, you will get this term, expand the RHS of the summation, by giving values for n. So b1, b2, b3, etc. Compare LHS and RHS. So u0 is compared to this term because you have pi x, pi x. So u0 is b1 and remaining terms are 0. So you end up with u of x comma t as u0 sin pi x by l into cos pi ct by l. In the same way, I am taking the next problem. Solve utt equal to c square uxx given that, again if you observe, the first three conditions are same till here. So you have to derive the first three conditions like how I did in the problem 1. All the derivations till you get u of x comma t and you represent it in summation, that is u of x comma t equal to bn sin n pi x l. And the last condition you have to use as u of x comma 0 as u0 sin cube pi x by l. That means when t is 0, this is the value. So we have substituted, but since you have sin cube here, I have to convert this RHS bn sin n pi x by l you have. So this LHS has to be converted. So sin cube theta, from the formula of sin 3 theta, sin cube theta can be written as like this. So in the place of theta we have pi x by l. So I have substituted and expanded the summations and comparing what is b1, coefficient of sin pi x by l is 3 by 4 u0, b2 you don't have 0, 3 pi x by l minus u0 by 4, etc. So at last, by using the values in the main summation, you end up u of x comma t as 3 by 4 u0 sin pi x by l cos pi ct by l minus u0 by 4 sin 3 pi x by l into cos 3 pi ct by l. So whatever the problem in wave equation, the first three conditions you have to derive till u of x comma t equal to summation n varies from 1 to infinity bn sin n pi x by l into cos n pi ct by l, and at last you have to use the last condition and complete the problem. Again I have taken another problem. The same conditions are given, but the last condition they have given as f of x. So the first three conditions till here you have to derive like previous problems. The first three conditions you have to derive, take the general solution, put all the conditions, and you end up with this equation, and then you end up with another equation, that is u of x comma t equal to this one. So till here it is same for any problem, and then we use the last condition. So the last condition is given in the problem as u of x comma 0 equal to f of x. F of x is defined. So I have using the last condition, when t is 0, u is f of x. So I have written this f of x. So t becomes 0, cos 0 becomes 1. You end up with this. This is nothing but half range sine series. So you can write bn 2 by l 0 to l f of x sin n pi x by l. F of x has two intervals, 0 to l by 2, l by 2 to l. Two functions are defined. So I have splitted the terms, 0 to l by 2, took common all the constants, and x into sin n pi x by l, you know how to integrate, Bernoulli's rule. L minus x into sin pi x by l, also Bernoulli's rule. So you end up with this result as bn, and you substitute bn in the main equation. You end up u of x comma t as this term.